Morning guys, today we'll be doing mathematics. This is question 1, solve for x, taken from the metric paper written May June 2019. Because this is a revision video, we're only gonna be concentrating on answering 1.1.4 and answering 1.2. Please stay tuned. As this is a revision video, I'm only gonna show you the steps, but for an in-depth way on how to go about solving different sums concerning this specific rule or the exponents rules, please watch this our solve for x exponents rules video. Now I've already written the sum down. The reason being, I need us to spend more time talking about how you answer this specific sum. Firstly, it's important to number your sums correctly. This is 1.1.4. Number it clearly and leave a distance, a sizable distance between where you start your sum and where you've numbered your sum. Now, make sure firstly that when you copy your sum, it's exactly as it is written on the question paper, because sometimes you copy it wrong and you end up solving a wrong sum and therefore losing marks along the way. Now I've copied the sum as it is written on the question paper, and the question says I must solve for x. Now in the second step, I'll call it the second step, but it's actually the first step of solving the sum. I've looked for coordinates. I'll take it that you don't know anything. So the brackets that I've written there are the coordinates of the numerator of the sum. Now I've simplified it to that so that it becomes easier for me to can solve the sum. And when you find the coordinates, because your mind will be working hard to finding the coordinates, you may forget that you still have an equal 4 on the other side. It's very important for you to go back and look at the original sum and make sure that there's nothing you forgot. I'm sorry guys, my video is a bit, I hope it's gonna solve the problem now. Yes. Now I've repeated the second step because I wanted you guys to see that in the first instance we were looking for coordinates. Once we found the coordinates, we wrote on the third step exactly what is on the second step, because I want you to see that you then have to cancel the like terms. Now you move down, you concentrate on what is left after you've cancelled. You are left with 5 to the power of x minus 1, which is equals to 4. But now people would be wondering, if you have coordinates 5 to power x, when you times 5 to power x by 5 to power x, people will be saying, but 5 times 5 is 25. It doesn't work like that when you deal with exponents. When you deal with exponents and the bases are the same, you keep the same base. Since the base here is 5, you keep the same base, you just add the exponents. So if I say 5 to the power of x times 5 to the power of x, I'll keep the base as 5, but I'll just say x plus x is equals to 2x. That then gives me the numerator as I return it. Now, if I have a minus, in fact, then I'll cross and say 5 times the positive 1. 5 to power x times the positive 1, I'll have a positive 5 to the power of x. And when I say negative 1 times 5 to the power of x, I'll have negative 5 to the power of x. Now, those cancel out because they're the same and they have opposite signs, so they cancel each other out. That is why then I don't have a middle term. We'll talk about that later. And when I say minus 1 times a negative 1 times a positive 1, it's gonna give me a negative 1. So that's how I got the coordinates. But like I said, this is revision. I take it that you know how to go about dealing with exponents. If you do not know how to, please watch the solve for x exponents rules. After you've cancelled out, you're gonna be left with 5 to the power of x minus 1, and you need to equate it to 4. The negative 1 goes to the other side and it changes its sign to a positive 1. When you add it to 4, it becomes 5. In exponents, that is, or that should be your goal, to make sure that you have the same base so that you can add or subtract the exponents depending. Sometimes you add the exponents, sometimes you subtract the exponents. But for now and for today, we'll concentrate on this one. Now, 4 plus 1 is equals to 5. Great, because our bases now are gonna be the same. Now, don't ever confuse 5 with 5 to the power of 0 because you don't see a number there. Any number to the power of 0 is equals to 1. Please play around with numbers on your calculator. You will see any number to the power of 0 is equals to 1. If we had a 1 there, let's say we had 5 to the power of x is equals to 1. We could have changed it to 5 to the power of x is equals to 5 to the power of 0, so that we make sure that our bases are the same, and we could have then said x is equals to 0. But now, a number, a natural number, will then have a power of 1. That is why I have put it there as 5 to the power of x is equals to 5 to the power of 1. 5 to the power of 1 is as good as 5. So it would have been any number. It would have been 25, it would have been 100. Then we would have changed the base. But for now, let's just, because you're gonna be confused, for now, 5 to the power of 1. Because the bases are the same, we forget about the bases, then we concentrate on the exponents. That is why our answer then becomes x is equals to 1. Guys, it is very, very important that you watch the video Solve for X Exponents rules, because it then shows you how to solve exponents when they are fractions, when you have to take out a common factor, when you have to deal with coordinates, when you have to change your base, and work around what you have. It's very, very detailed. It may take too long, but it is very, very detailed. This was a sum, and I think many people did not get this, but this is how you do it. And in the exams, you'll be very, very distracted and not remember how to deal with some of the things, because I don't think people know that exams come with its own pressures. But this is how you answer the sum. I hope it helps, and thank you for watching. Bye.